All right, welcome. Section 15.3, permutations and combinations. Exciting stuff. So let's just jump right into it. So permutations is going to be kind of the first thing we're working with. And this is when the order is important. The most challenging part of this section and this chapter in general is kind of deciding whether to use permutations or combinations to solve each problem. Okay. Once you've decided that, most of it is just calculator commands. So it's kind of really important to start associating permutations is when the order matters. Okay, order important. So an example of that is we can kind of introduce it with this problem here. Suppose that a club with 12 members wishes to choose a president, a vice president, and a treasurer. How many ways are there to fill the 3 offices? All right, so we're going to solve this very similarly to problems that we were solving in the last section. Okay, you can kind of think of it as the 3 positions. There's like 3 slots. Okay, the president, vice president, treasurer. All right, and so let's say we're filling the president role first. We have 12 total members. All right, so there's 12 possibilities for that president. And for the vice president, since we now chose that first person for the president, there's only 11 possibilities. And by extension, there would only be 10 possibilities for the treasurer. All right, so it's going to look just like those problems we did in 15.2. 12 times 11 times 10. And there are 1,320 ways to fill those 3 offices. Okay, why the order mattered here is because if you, a person being the president versus the vice president are different positions, okay, as opposed to this next example, which is about combinations. Okay, this is where order is not going to be important. So we have, suppose that same 12-member club wants to choose a governing council of 3 people. How many ways are there to fill the council? Okay, in the previous example, if you had person A be the president, person B be the vice president, and person C be the treasurer, okay, that would be different than person B being the president, person A being the vice president, and person C being the treasurer, and all those different kind of configurations of that. Here, if this is just a 3-person governing council, these 2 situations, ABC being on the governing council and BAC, those are counted as the exact same. Okay, so we got to kind of think of a way to kind of change our work from the first problem to try and get it the same way here. So let's kind of start with how many different ways are there to organize those 3 people. I don't know why I erased that. The A, B, C. Okay, so and you could just list them out, but it's going to take a while. So we can kind of just use our same logic of the multiplication principle. I know to fill the first slot, there's 3 different people. So 3 times 2 times 1, okay, which is the same as just 3 factorial, or 6. So there's 6 different ways to do it. And so we know if the total number of governing councils okay, times 3 factorial, or times 6, is going to equal the total number of slates of officers. The slates of officers being what we solved in that previous example, that 12 times 11 times 10. So we can kind of start filling that in, because all of these situations here, the different combinations of ABC, BAC, CBA, all of those were counted in this one, but we do not want to count them in here. So we know how to figure out this first part on the right. That's just 12 times 11 times 10. And to get the total number of governing councils, I'm just going to divide that by 3 factorial. 3 times 2 times 1. And that'll get me the total number of governing councils. Okay, so 12 times 11 times 10, that's just that 1320. Divided by 3 times 2 times 1, which is just 6. We get 220 ways. Okay, notice right now that for permutations it was 1320, for combinations it was 220, with very similar scenarios. The permutations where the order matters is going to always be a lot bigger than when the order is not important in combinations. All right, so let's kind of formalize what we just did there with some equations. So these are the 2 equations for permutations and combinations. If n is the total number of objects in the set, so thinking about our last 2 examples, that would be n, the number of members, which was 12. And r is the number of things we're trying to choose. So in both examples, we were trying to choose 3 objects. So what we found for that first one where the order mattered, that was 12p3. Okay, and notice how, so what we would do for that permutation is that 12 factorial, 12 times 11 times 10, etc., divided by the n minus r factorial. So that would be the 12 minus 3, which is 9 factorial. And notice that all of these terms start canceling out, and that's why it kind of just simplifies down to that 12 times 11 times 10. For combinations, okay, what we found in the second part, we were trying to make a governing council. We were trying to find 12C3, okay, and using that formula, the n factorial divided by r factorial and minus r factorial. Okay, so the n factorial there is just the 12 divided by the 3 factorial, that's just r factorial, and then n minus r factorial, so 9 factorial. Okay, and once again, a lot of those terms start canceling out all the way down. And we're just left with the 12 times 11 times 10 divided by the 3 factorial. Okay, so that's how those formulas work. That's how we're going to use them going forward. The main kind of challenge here is figuring out whether it's a permutation, and that's going to be when the order matters, or if it's a combination and the order does not matter. All right. There's a few calculator shortcuts for how to do these. They're found in the Math Probability menu. So you need to go click the button that says Math. It should be on the left side of your TI. And once you're in the Math menu, scroll all the way over to PRB. Stands for probability. All right, you find a lot of stuff here, but it should look like this menu right here. And these are the 3 that we're interested in. Okay, the first just being for permutations, second being for combinations, and then the fourth one just being for a factorial, if you want to use that. The major annoyance here is that you have to kind of put when you're trying to do like an NPR, so let's say we are doing 12P3, just like we did in that last example. What you have to do is you need to put the 12 first. So you'd put 12 Then go to that math probability menu and hit MPR. And then once it brings you back to the home screen, hit 3 and then press enter. And it should give you the same thing that we got from the results of the previous question. Okay, so those are going to be helpful. And NCR works the same way. You got to put the initial value first, head to this math probability menu, choose the NCR option, and then it'll bring you back to the home screen. You put your final number there, hit enter, it'll get it for you. All right, so let's just run through a few examples here, kind of get used to determining between combinations and permutations. So here, part A, we have company advertises 2 job openings, one for copywriter and one for an artist. If 10 people who are qualified for either position apply, in how many ways can the openings be filled? All right, so here the order is going to matter because we have kind of these 2 distinct positions. Okay, so it's very similar to kind of that president, vice president, treasurer type thing, except here we have copywriter and artist. So since the order matters, it's going to be a permutation. With N, the total number of people in the set is 10, and R, the number we're trying to choose, is 2. Okay, so it's going to be as easy as 10P2. Okay, so if I just throw that in my calculator, get 90. Awesome, not too bad. For part B, company advertises 2 job openings for programmers, both the same salary and job description. So here, the order does not matter. Those are the same 2 positions. Okay, as opposed to part A, where if like person A is the copywriter versus person B being the artist, that's the opposite is a different kind of case. If A is the artist and B is the copywriter. Here, there's just 2 programmers, so the same kind of thing. Choosing person A and B, it's the same for both. So order doesn't matter. So we know we're going to do a combination. Okay, with the N and the R from part A still applying here. So it's just going to be 10C2. And if I use the calculator commands, get 45. Okay. Notice it's pretty straightforward to do this without using those calculator commands, just using the equations. To do that for part A, it would just be, well, to kind of think of it the same way as those number of slots that I've been talking about. So for the first position, for the copywriter, there's 10 people. Second position, there's 9 people. 10 times 9 is going to equal 90. For the combinations one, if you want to use the formula, it's just 10 times 9 over 2 times 1, which is just 90 divided by 2, gets you 45. All right, so very similar example here. We have a raffle, 845 tickets, just with some bigger numbers here. So in how many ways can 4 $50 gift certificates be awarded? All right, so the prizes are all the same here. So the order does not matter. So this is definitely going to be combinations. Hopefully you're starting to pick up on something in kind of the pattern. If the order is going to not be important when the things you're choosing are all the same, and that's been the case for all kind of 3 of our examples so far. So we have 800 this is going to be with N being 845, R being 4. So it's probably just going to be easiest to use the calculator command here. We'd have 845 C4. And get a massive number. It's going to write at 2.1 times 10 to the 10th power. Okay. The next example, in how many ways can $100, a $50, a $20, and $10 gift certificate can be awarded? Here, each prize is unique, so the order does matter. Getting the $100 is different than getting the $10, as opposed to, for up here, they're all the exact same. Getting any one is all the same. So that's going to indicate this is going to be permutations. But otherwise, the same thing is true. N is that 845. R is still the 4. We still have 4 total. So 845 P4, which would get us. Plug that in the calculator. 5.06 times 10 to the 11th power. So you can probably notice the numbers here are going to get pretty massive pretty quickly, and that's pretty much always the case when you're dealing with factorials. All right, in an effort to keep this video fairly short, this will be our last example. So we have a diner. An omelet can be ordered plain or with any of the following fillings: cheese, onions, and peppers. Pretty basic diner. Can't even get any sausage or bacon going. So how many different kinds of omelets are possible? All right, so this one's a little bit more complex. So there's kind of different ways the customer can choose an omelet. He can choose it with number of fillings. He can choose it with 0, 1, 2, or 3 are all possible. Okay, so we're going to have to kind of think about each of these situations and then kind of add them all up. So the total number of 0 filling omelets, that's just going to be, and also this is going to be combinations here. The order does not matter, okay? Because, I mean, a cheese and onion omelet is the same as an onion and cheese omelet. So the order does not matter. So we're just going to be using combinations, just a few different possibilities for the number of fillings. So basically, if the n here is 3, okay, and we're just going to have basically 4 different situations of the number of r. So it's just going to be kind of set up as 3C0 plus 3C1 plus 3C2 plus 3C3. All right, so 3C0, that's just going to equal 1. I think you could probably figure that out without even doing it on your calculator. There's only one type of plain omelet, so that's just going to be 1. 3C1, how many different ways are there to choose omelets with 1 filling? Well, that's just going to be, you can either get a cheese, you can either get an onion, or you can get a pepper. You can confirm that 3C1 equals 3 on your calculator if you'd like. 3 choose 2. Okay, so just using the formula really quick here, that's just going to be 3 factorial over 1 factorial times 2 factorial. So that's just going to equal 3 again. So we'll have, so far we got 1 plus 3 plus 3. And for 3 choose 3, that's just choosing all of the fillings. There's only one way to do that. So plus 1. 1 plus 3 plus 3 plus 1 equals total of 8 omelets. All right. So now that you're sufficiently hungry, I'll wrap up this video. Have a good one.